And now I'd like to introduce our first speaker, Geoff Huston. And we're going to open with Geoff, who is going to tell us about some surprising findings he has on the behaviour of resolvers when selecting the nearest authoritative server. It's not what you'd expect.
Thanks.
Thank you.
Good morning, all. Look, it's great to be back here again in person. Most of my body is now working. This is great. This is actually triggered by a talk last October, I think it was, from a gentleman from Cloudflare, who was giving us a presentation on trying to measure the performance of authoritative name server platforms. And you kind of think about this a bit, and you can't engineer the authoritative name servers without understanding how recursive resolvers actually query them. And so it's kind of a package of how do name servers work and how do recursive resolvers use them. And the questions that were in Joao in my mind, because this is joint work with Joao Damas over at APNIC, is when you've got a choice as a recursive resolver, how do you figure out which one is the best one to ask? How is that choice actually made? And of course, like everyone else, what you want to do is maximize two things, and they might be in conflict sometimes. Maximize performance, get the answer fast, but also maximize resilience. Have something in your back pocket that you know is up. So if the first one doesn't work, you can immediately flick to the other. So this is about what happens when you've got a cache miss and you go back to it and ask, what's going on? There has been some recent-ish work. This one is 8 years old. It's not brimming with papers and activity, but this is joint work with, I think it was at the time, SIDN and ISI with John Heidemann, and the summary of the paper is there. Their bottom line is, use Anycast. And we'll see why that's actually an expensive but really necessary answer if performance and resilience is part of what you're seeking. There's much more recent-ish work. Only a few months ago, Shimon is a co-author with some Chinese participants, which is also really interesting because it tries to break down the most popular resolvers, bind, unbound, not power DNS, Microsoft DNS, and actually in looking at the code, figure out what's their algorithm to select the best authoritative name server when given a choice. Interesting, worth reading. And then the RFCs. And this one is a classic of its time. It was a different IETF, wasn't it? Nothing about performance, nothing particular, batting average. As an Australian, what is a batting average? 34 runs per inning? You know, what is going on here? Bizarre. We wrote RFCs differently in those days. So I did a couple of measurements, and the first one was desktop. So, you know, set up something really simple, 4 unicast authoritative name servers. So there are 4 of them, there's nothing Anycast special in here, and I set up a client and I just go and ask it. And I track which query. Now, to make sure that this is really a definitive choice, I set up the name servers in those 4 points. And I put on the slide there the differences in delay to get between each of them. So there will be, well, no matter where you are, there will be a fastest and there will be a slowest, and it will be obvious. So what I'm expecting to see is you find the fastest and you hammer it for every cache miss. You just go to the fastest. But at the same time, regularly, for some value of regularly, you kind of poll the others to make sure you're alive, you're waiting, and if the first one disappears, I can instantly switch over. That's what I expect. Time is the thing at the bottom. Those are the 4 name servers across the side. Right, by 9. Not quite what I was expecting. I'm in Australia, and Singapore is close, and it does go, I'm going to hang out Singapore. That's fine. The next closest is actually the top line, if I can get that right. Server number 1, I think that was actually in Europe. No, it wasn't, it was in India, that's right, and it is closer. And it hits it more frequently than the ones in Europe and America, and in fact, America is hit more frequently than Europe. And if you think about it from Australia, America across the Pacific is slightly faster than Europe, which is a long way away. So bind doesn't regularly check the others, it seems to do it in some proportion to its delay. The further away you are, the less frequently you get that query to say, are you still alive? That's the way it works. Unbound. Whoa, guys, what are you thinking? This is weird. It doesn't like Europe from Australia. Well, I don't know. I think the rest of us in Australia are pretty okay about Europe. But, you know, not unbound. And the others, wow, Mumbai and Atlanta seem to get hit about as frequently as Singapore. It's kind of fastest when fast means anything within this half of the world, which is a weird definition of fast. I don't understand that. Maybe Unbound does, but that's great. So even in the lab, things are getting a bit curious. Google. Now, it's Anycast, so I'm hammering it away at the Google point of presence. I've forgotten, I think I'm in Sydney. And you'd think Google, across these 4 name servers, would go, you've asked me in Sydney, the fastest one to respond is going to be in Singapore, I'll ask Singapore. No. I'll ask everyone. I have a slight bias to Singapore, but, you know, what the hell? You've got all the time in the world, haven't you? I don't have to be fast. I find that rather bizarre, but, you know, that's Google. Cloudflare, again, kind of weird. I really like the 2 fastest, the 2 closest, and I'm not too keen on America, even though, from where I am, America is faster than Europe. And again, it's sort of, this is a surprising outcome. You'd think, although I'm asking the closest point inside Cloudflare, Cloudflare's splaying the load across the name servers quickly, but there are biases. And I'm really not quite sure how that bias in Cloudflare got set up. So again, I put that as an eyebrow-raising answer. No common behaviour. Go read the rest of it. I'm running out of time. So now, let's big it up. Let's really big it up. I'm going to ask 30 million people all over the globe in a day, and I'm going to keep that going for a week. So I'm going to ask all of you. Now, I'm going to use the same 4 authoritative name servers, but I'm now trying to trigger a whole bunch of recursive resolvers to go and ask them. And I'm interested in their selection. What is, from my perspective, the busiest recursive resolver on the planet? Well, it's Bharti Airtel in India, because they tend to siphon or push all of their DNS queries through a very small number of engines, and there are an awful lot of users of Bharti Airtel. An awful lot. We're talking hundreds of millions. So it's in India. It doesn't ask America, really doesn't ask America in 1 hour, but it doesn't seem to mind sending queries to Frankfurt. That's a long way away. Even if I stretch it out to 12 hours, it asked Atlanta twice. You alive? Yeah, cool, fine, I'm going to ignore you now. And it seems to have a preference, maybe Singapore over the one in Mumbai. Wow. What's so bad about the one in Mumbai other than it's right beside one of your pops? I'm like, really? And when you summarise this for 1 week, what you actually find is that the attachment time is latched against Singapore, but it also spends a lot of time asking the one in Frankfurt and a much lesser time asking the one down the road. That is really weird. Now, I do this for the biggest 100 recursive resolvers that we flush out. Why only 100? Well, I'm using unique domain names in this test, so there are no cache-hits, but I want the resolver to pound pretty frequently. So I find the resolvers where the ad campaign that we're using is generating a whole heap of queries, so I get a huge amount of tests against my tiny unicast network. And what I find in this graph is the circle, those horizontal lines as each of those pops, as usual, the circle is the greater the diameter, the more the attachment. Now, you'd think, if you read Schumann and his colleagues' draft, that the attachment to the fastest would be pretty solid. So what you should find is, for every vertical line, which is 1 recursive resolver, the IP addresses are written there very clearly in 1-point font. For every recursive resolver, there is a clear closest. these 4 servers are all over the globe, it should be one big dot and 3 little tiny dots. That's not what we're seeing. There are a few with strong attachment, but there are other vertical slots that go, oh no, I'll display the queries around the world, I don't care. So I took 1,000, only 60%, 600, showed a strong attachment preference. More than 2/3 of the time they were asking one of my 4 authoritative name servers. The other 40% of the recursive resolvers went, we don't care. No attachment preference. And if you do that threshold at 40% of the time, a bit lower, 53 out of those 1,000 simply said, I don't care. I'll just keep on asking everyone. The next question. Okay, so you've attached to one of my 4. Was that the right one? Was that the one that's closest? Well, what's closest? Well, they're Linode servers. Joao and I log into them. They're ours. So we just ping your resolver. So we ping them to give round trip times. So here's an example, free.fr in France, proxad. Here's the RTT measurements against that IP address from each of the 4 locations. Now, you'd think at 9.8 milliseconds, this thing would be asking Frankfurt, because, you know, even though it's in Germany and they're in France, we're still all friends in the EU, aren't we? And so, you know, it's cool. Yet, 70% of the time, this recursive resolver operated in that network has a strong attachment to Atlanta. I have no idea why. I guess that the folk who operate this resolver don't either. So out of those 661 that had a strong attachment, then you kind of go, and I pinged only 500 because the others didn't respond. Of those 500, less than half have made a good choice, and the others had made a dud choice. So the next question is, how bad is the dud choice? This is the distribution of badness in terms of timing. The vast majority of recursive resolvers that made a dud choice seems to plateau at around 100 milliseconds of error. They got it wrong, and not just by 1 or 2 milliseconds. Don't forget, these 4 servers are at various parts of the planet. They got it wrong by more than the width of the Atlantic Ocean, more than the width of the Pacific Ocean. They got it wrong big time. There's one even that got it wrong by 420 milliseconds. You've got to really try hard to get an error that big. You've got to deliberately engineer, oh my God, we really want to stuff up users because we really don't care. So that's an interesting kind of badness going on. No one wanted this to happen, but that's what we see. So what it's telling us, recursive resolvers do a lousy job on average. Some of them do a really good job, and that's great. On average, you can't count on them. What does that mean? Well, if I own a domain name and it's really valuable, then I can't rely on recursive resolvers. So even if I spread name servers all over the planet, they're not going to make the right choice. They're going to make a dud choice. So I have to do their work for them. I have to do Anycast. I can't let the recursive resolver choose. Do you? So there's 2 kinds of ways to test that hypothesis that the authoritative name servers are running around you. You take the small, exclusive, artisanal set of domain names where folk really, really, really care. The beauty of that when you take the root zone is there's only a small number of zones, and I'm going to tell you about that. If you really want to see about the great unwashed, you take any of the large data sets of 1 million domain names. That's a lot of work. We didn't get it done in time to present it here. So I'm going to present the root zone. 1,445 TLDs in that root zone, 6,000 authoritative name servers by name. Interestingly, there's this folklore out there that you either have 4 or 6 name servers for your name. Why is 5 evil? I'm asking you guys because I have no idea. But for some reason, 5 is a bad number. And so is 3. And interestingly, although 6 is cool and it's the most popular, 7 is almost the least preferred. What is so evil about the number 7? It's kind of, well, we don't do 7. Bind actually goes up to 7 before it gives up. 8, which has a fair deal of presence there, Bind tends to say, no, I'm not going to, if everything's failing by 7, that's it. I'm not even going to test the 8th. So anyway, for only 321, dual stack, almost everything. And there's 3, bless them, that only seem to have a v6 address for the name server. So no one's really going v6 only in the root. But then the real question is Anycast versus Unicast. So again, it's very hard to tell from the outside. And I'm not going to ask them, I'm going to do this by measurement. I've got these 4 name servers, I've got these 4 points of presence, Linode, so I query the NSID. And I also look at query times. If you're in one data center, I'll get massive variance. If you've got a fantastic Anycast system that has points of presence in Berlin, Paris and Amsterdam, I'll still get a pretty crap answer, but it will be slightly better than nothing. And if you really are all the way around the world, I'll get really low variance no matter where I actually ping it from. So, 9,000 unique IP addresses. In the root zone, where we carefully look at every single packet, because these are valuable zones, and they're the only zones that can afford their own teams of people to actually look after them, there are only 587 unicast addresses. Big hint, don't mix unicast and anycast. Because the recursive resolver is going to periodically flip over and ask the unicast just to make sure it's alive, so you introduce extraneous performance penalties. For those 587, don't do that. Limited unique anycast, they're not everywhere. They're sort of there, but no one really checked, the vast majority. And a smaller number, 2,500, which really are for those 4 locations on the major sort of continental areas of the world, really are there. The RTT variance is less than 150 milliseconds. So these are the stats. Read it over at your leisure. There are 8 TLDs, God bless them. They're all CCTLDs, what a surprise, that are served by only unicast. Keep on banging the rocks together, folk. You'll get somewhere. On the anycast, there are 1,000 out there that are served by anycast. Diverse, 289 really are around the world. A much smaller number is kind of a little bit around the world in various ways. AS diversity, well, we said 6 or 8 name servers, but they're actually really operated by between 2 and 4 origin ASs, 2 and 4 networks. Each TLD is actually served on average by 3.4 origin networks. So that's a reasonable amount of diversity, yes? That's a lie. Vietnam, for example, runs in VNNIC 10 ASs, 10 of them, by one entity. So it's not really diverse, same location, same platform, same, but just 10 different ASs. What don't you trust, BGP? Because realistically, what I'm after is not just discrete IP addresses, I'm after discrete points of presence, discrete locations. I'm trying to remove single points of vulnerability. And if you actually look at the organizations, a lot of even the big providers run multiple ASs, but duplicate everything. That's not really diversity. That's just ersatz diversity, so it complies with your purchasing order. Must run diverse multiple anycast networks. Yes, we do that. All in our own network. Yeah, great. So my observations as I come to a close here, DNS recursive resolvers, for some reason or other, despite the code, actually make pretty crap choices. They're not very good. So when you only give it unicast, it will get it wrong. It'll get it wrong by up to 150 milliseconds. Not a good idea. Second, anycast is really good, but anycast in one area of geography doesn't really help you. If you're going to do anycast, go big, go all over the place, because that way you're close to everyone and the routing system doesn't need to work very hard. Go to an anycast platform internally whose average AS path to reach everywhere is as close to 1 as you can get. One that's adjacent to every stub. That's the anycast kind of platform you need. And thirdly, multiple is good, 8 is overkill. 6 is overkill. 2 is just on 1 and a spare. And if that makes you nervous, go for 3. 4, I suspect, you're wasting your money. They've got to be truly diverse. They've got to be truly independent. And in all kinds of observations like this, but DNSSEC is a real substantive question. Because if you're using online signing at front ends, you've got a key distribution problem that almost invariably fails at the worst possible moment. Ask anyone who's tried it. So there's much to do in this space to actually make it better. I've now looked at the Tranco Top 100. It's on a blog site that we run in potteroo.net. And who knows, we might talk about it later when there's more to talk about. And that's the end of my presentation. Are there any questions?
So 2 questions. You said for a bunch of things, oh, sorry, Warren Kamari, Google. You said that the resolver generally flips over to another authoritative and sends a query, right? It sends a bunch of them to one, then flips over, sends. Have you looked to see if some resolvers are sending duplicates? So send all of them to the fast one and send a duplicate every now and then to a backup, because that would skew the results wild.
That's a really good question, Warren, and I'm not saying that just to be polite, because these days it's fashionable. That's a really good question. We were struggling hard to meet the submission deadline and just set this stuff up and just go, that's the objective, bang. Did we look at other shit along the way? We didn't have time. It's an interesting question, and in my fallible brain, if I can, or Joelle can note it down, we will have a look.
Okay, and then the other short one is, for things like people not asking Atlanta, did you check to make sure that all of the name servers answer about as quickly and are about as performant, like not packet loss?
They weren't doing much else at the time. These are Linodes, you know. We seem to have ample capacity and bandwidth. Thank you.
Hi, I'm Ben Schwartz, but I'm relaying some questions first for Dave Fellman in the chat, who asks, you've mentioned that this is dual stack and have highlighted v6 addresses specifically. I wonder if you have any data for v4 or v6 only, as in my experience, this dramatically affects routing decisions, latency measurements, and so on.
The test we were on the lab was v4 only. The larger test with the ad, with about 30 million times 8 days, was dual stack. It didn't seem to alter things much, but it is an interesting question. A good Anycast network is beside every AS. Routing doesn't matter because everything's AS hop length of 1. After that, it depends on the quality of your v6 routing. Yes, I know India used to route v6 through the United Kingdom because, but those kinds of massive routing stuff-ups in v6 thankfully have largely disappeared, and that's a good thing.
Puneet Sood of Google asks, are you counting IPv4 and IPv6 separately for the count of unique nameserver IPs?
In a count of unique nameserver IPs, yes, we are. All those stats for IPs were v4 is 1, v6 is 1. Like resolvers, once you get rid of the name and have IP addresses, you don't care how you derive them. You have a handful of IP addresses, yes.
As Ben Schwartz, I will note that this might explain why you see even numbers.
Why I see even numbers? Yes, you are right in this data set. When you go to the Tranco Top 1 Million, where dual stack is not fashionable because spending $1 on your name service is considered a sin, there's an awful lot of v4 only. So yes, it's a unique, the route is special because people look and people work on it. The Tranco Top 1 Million is the dross of the internet. Even 1 cent is spending too much, sadly. Thank you.
Okay. Puneet is actually right here, so I don't know why I'm relaying these questions.
Neither do I, Puneet. He's down here in the middle of the front row, and we're making eyeball contact as we speak.
Puneet also asks,
Enough.
if the query rate is 1 QPS, did you perform any testing with higher QPS?
Again, timelines and everything else. Thank you for your question. It's something we could do if we had, a year to prepare the slides. We were in an awful hurry. Thank you.
I think we've just got time for the other 2 questioners at the other mic.
Stefan de Bink, SRDN. I was wondering if you have looked, probably not because no time, but at the BGP impact of the things, because resolvers can shift to something different because they get in somewhere and get out somewhere else
And this actually explains some of the issues that when you think you're at the fastest, you should always check the others because BGP, because things change, and it's not necessarily that it goes down, but someone else becomes faster. So the whole idea of periodic querying others is good, but I don't understand why it's more than periodic. Like Unbound just kind of goes, well, I've got 4, I'll just hammer at 3. That's kind of taking it to excess, might I suggest, Mr. Unbound people and Ms. Unbound people.
Thank you very much.
Yeah.
Raffaele, University of Twente. Thanks, Geoff, for the talk. I have a question. You said at the end of the day, ANICAS is like a better solution, but ANICAS comes with its own problem of saying we are basically just trading the choice of a authoritative Nameserver that resolver does with whatever the BGP thinks is the best route if we use ANICAS.
And this is why I suggest dense, diverse Anycast, and that's why I made the distinction. Having an Anycast network with a few nodes somewhere in the North Pole is really not Anycast, it's ersatz. You really need to be everywhere. So I made a big distinction between, from those 4 vantage points, I need to get the variance below 150 milliseconds to make sure that there was a point of presence nearby-ish to eliminate BGP stuffing me up. And in the grand scheme of things, an average AS path length of 1 is ideal.
Yeah, thanks.
Thank you.
Is it a quick question?
Oh.
Yes. So I'm Stepan Balajic. I now work for ISC on Bind, but I have written my bachelor thesis on server selection in DNS resolvers, and I rewrote the server selection algorithm for not resolver. So that's about the context. And I'm going to ask, you showed the behavior of bind and bind 9 and unbound, which I know they are particularly, they are not preferring the fastest authoritative servers very well for various reasons. But I know that Power DNS and the newer versions of not resolver D, is there a reason you didn't present those?
Joao and I had a morning. We needed to get the thing up and running by 10 o'clock. Bind, unbound, like that. Everything else, oh God, takes too long, didn't do it. Simple as that.
Okay.
I'm really sorry. We're going to have to call time
Yep,
on this
thank
now.
you.
Sorry, Ralph, but you can do it in the channel afterwards.
Thank you very much.
Thank you so much, Geoff, for that fascinating talk.